Hello again, and welcome to Spark App League's teacher training. This is week 3, session C, and we're talking about design this week. As before, I have a couple of quick announcements to make at the beginning, and then we'll jump right into the training. So to start, we are opening student registration today, so teachers that have previously registered your classes, you'll want to go to our website, sparkappleague.com/register, and have the students register their teams. Students can register their teams in either groups of 2 or 3, and they will have to choose their school and the sponsor from your school that is going to be accompanying them at the event. But please make sure to do that before October 27th. We need a final head count of how many students are going to be attending the event by October 27th. So it's very, very important that you guys get those student registrations in. We also have a wait list of teachers that are not available because we're currently at capacity. And so any remaining spots that haven't been registered by students by the 27th are going to be given to people and students and teachers on the wait list. So it's very important that you do that. Secondly, we still have Christina Karaskia from ASU available to answer any kind of design questions that you may have. So feel free to leave them in the group chat here on the YouTube page for today's session. And then also you can leave comments if you would like on the actual YouTube video after the fact if you're watching after our training today instead of live with us. But either way, we can get you answers to any design or programming questions that you may have. So definitely please go in and do that. Today, we are going to go over the session that the project that we worked on in the previous session, which is the kitty drop game with the apples falling from the top of the screen. Our homework from the last session was adding a variable speed to the different items that are dropping from the sky. And then we'll also talk about adding some power-ups. Since this session is all about design, we're going to talk about some ways that you can take a game or an activity that you're doing in Scratch and modify it with either a new game mechanic or a modification on an existing game mechanic. So our modification for today is going to be a power-up that we're going to use. So let's get started. Let's load up our project from last week, or from the last session, I should say. So where we left off is with our game where Scratch the Cat moves around using the arrow keys. We have rotten fruit and regular fruit. The player has 9 lives. We're keeping track of a high score. And if the lives ever drop to 0, then the game ends and you have to restart the game to keep going. The high score is persistent. We haven't cleared it from play to play, obviously, as a high score is typically not cleared from game to game. But we're gonna start off by going to our scripts for both the good apple and the bad apple and modifying them so that the speed is variable. So we're gonna create 2 different variables for the Y speed. So we're going to have a good speed and a bad speed. So I'm going to start in our data section and just make 2 variables for bad speed and 1 for good speed. Now, you may be asking yourself, and we've done this with variables a couple times, but you may be asking yourself about what this option for all sprites and for this sprite only does. And that's just a matter of access. We've briefly touched on this in previous sessions, but the for all sprites option gives every object, including the stage, access to this sprite. Meaning, if we want some other object interaction to cause or to be able to cause changes to this variable, then we need to give that option as that makes every sprite, or that gives every sprite permission to access this sprite and make changes to it, or access this variable and make changes to it. Whereas for this sprite only gives this particular object access to that sprite. So while we could theoretically only give this object access to that variable, that means that changes in the rest of our program can't modify this good and bad speed, or this, in this case, this good speed. So we might have, as I mentioned before, a power-up or something that modifies that speed, and that power-up object may need to have access to this. So in that case, we don't want to have this only accessible from just this object. We want all of our objects to have access to them. All right, so for now, I'm going to leave bad speed and good speed showing on the top part of the screen here. If you were in our previous session, you know that we talked about the UI and how we don't want, and UI is user interface, we don't want the user interface blocking our game because players need to be able to see stuff as it's dropping from the sky. So we don't want to leave these items up here at the top. But for now, just in testing and making sure that our speed parameters work, we do want to leave those up at the top just so that we can see them. And so they're not blocking a different part of the screen. Again, we'll remove those later. So to start, we'll start with the good apple. And basically what we want to do is change this option here where our Y value is, okay? And so there's a few different ways that we can do this. We can either take this position and make it a parameter of 2 values, meaning that we'll have like a Y speed of -1 at all times, and then there's a modifier or something that we multiply it by. So we can have either a modifier where our speed changes that way, but it's always going to be a negative number, or we can just make sure that our bad speed is a negative number and then just drag that in here, okay? It's kind of important that our speed, again, unless we're doing a power up that causes the fruit for whatever reason to temporarily move upwards, we always need our speed or our Y change to go down by a negative amount. So you just have to make sure, again, there's always more than one way to do this. You always need to make sure, though, that it's a negative number. So I'm actually going to just use the bad speed, or sorry, in this case, the good speed, as my actual value. And I'm going to set that good speed initially to just be -1. Okay, and actually, we're going to move that into our stage. So we've got some other variables that are set. So we're going to set those as well at the beginning of our game. So as of right now, if I set good speed to -1 and bad speed to -1, and then come in here and replace these values, our game works exactly the same way that it worked before. Our speed is -1, and that always stays the same. But now we can change that speed depending on certain things. So what we're going to do is we're going to look at the score. We have a couple different places that we're already checking the high score and other items on the stage. So we're going to continue with that. And basically what we're going to do is we're going to take our value for good speed, and we're going to change it every time the player hits a value that is a multiple of 10. Okay, so every time the score hits 10, 20, 30, 40, etc., that is going to cause the speed to go higher. Okay, so give me just a second. The way that we're going to do that is with a function called modulo. And this is kind of confusing, but the situation will come up very, very often. So we want to make sure that we're kind of clear on how the situation works. So getting things to happen when some other variable or some other number or some other item in your game is a multiple of a certain number is done with a kind of division, a division with a remainder. So basically what we're looking at, if we were to write this out in regular code, we're saying that if the current score is a multiple of 10, then increase the speed by a certain amount, okay? And the way that we figure out if it's a multiple of 10 is we divide by 10 and then check to see if the remainder is 0. okay? Because if our value, for example, is 15 points, if our score is 15 points, then 15 divided by 10 is 1 with a remainder of 5, okay? But 10 and 20 and 30 are all going to be 1, 2, and 3 respectively with a remainder of 0. And that's where this special operator comes in called mod or modulo. It's down here in the operator section. And I'm not going to input it just yet, but we're going to kind of play around with it a little just so that we can see exactly what's happening here and edit our good speed and bad speed so that they kind of work based on this. But we're going to do some testing first. So the first step is you have 2 blocks here in modulo, or 2 spaces. And both of these spaces can either use a operator with a round corner, or they can use a variable. Any of these round shapes can be inserted into here. So essentially, it's the first number divided by the second number, and this gives us the remainder. So our basic operation is we're trying to check if the first number divided into the second number gives us a remainder that's equal to 0. Okay, and those 2 numbers are our scores. So if our high score divided by 10 gives us a remainder of 0, then this becomes true. Okay, so I'm going to insert this into an if then else block. And I'm just going to organize this a little bit. So all of our score operations happen in the same spot. And we're going to set, let's just say a sound. We're going to play a sound if our high score is is evenly divisible by 10. So let's go ahead and play our game and see if that works. Okay, so bad speed and good speed are both set to -1. And we don't have anything yet that's changing that. But once we get to 10, we should hear a pop sound play. And since we haven't really introduced sound effects, this is a good way to play around with sound effects too. 5, 7, 8, 9, and now we should hear a pop at this point. Okay. Okay, now, just as far as sound effects go, you can choose different sound effects from here. We briefly mentioned the Sounds tab in our opening. So just like with the backdrops and the objects, you can add sounds that already exist. So we can add multiple sounds, and then when we go into our scripts block, we can change the sounds that show up or that exist. And I just realized that I was going based on the high score, not the current score. So we need to make sure we fix that. Okay, and here's one of those gotchas that I always talk about. So right now, our current score is technically a remainder of 0 because 0 divided by 10 is 0 with a remainder of 0. Okay, so we're going to introduce a operator that we talked about briefly last time, which is the AND operator. And the AND operator just checks to make sure that both of these conditions are true. Okay, so in this case, we need it to be divisible by 0, but we also need it not to be equal to 0. Okay, and we again briefly talked about these when we introduced them last time. But we also need our current score to not equal 0. So hopefully this makes sense. So we're saying current score equals 0 and then just flipping that around. So right now, our current score needs to be divisible by 10. So a division of 10 should give us a remainder of 0. And the current score should not equal 0. Otherwise, this sound is going to play over and over and over again, and we're kind of going to get sick of it. So let's, again, just test that. It's not playing right now, so that's a good sign. But we need to make sure that it does actually play when we hit 10. And I just don't want to hit any of those apples. Okay. So that played our sound a bunch of times. Now, we can always use some different sound effects if we don't want it to play all the time. We can obviously play sound until it's done and then stop if we want to. You can just play one beat if you want to. Now, because we do have this in a forever loop, this is going to check this all the time. So we need to make sure that you know, if you only want it to play one time during that, then you could also create another variable that says, you know, is this the first time that we've played this sound? And if it is, then go ahead and play it. Otherwise, don't play it again. We're not going to do that because we're not actually going to be using a sound after this, so we don't necessarily need that. But we do want the score to change. So eventually when we set up our good speed and bad speed, we will want to add that in so that our speed only updates once and doesn't constantly update every time, you know, this goes through. Because if the player is at 10 and hasn't caught another apple yet, then this code will fire over and over and over again. So let's go in and check our good speed and bad speed first. I'm just going to use negative 0.25 because it's kind of a nice slow speed. And then I'm going to set these to negative 0. Actually, let's leave them at 1 because otherwise it'll make testing harder because we'll have to wait longer for these to go. But eventually you'll want to play around with this to get a nice starting speed for your game as well. Okay, so now you'll see that issue that I'm talking about, but we'll work through this. Right now, we just want to make sure that that code is firing and that it works at least kind of the way that we intend it. Again, it's not going to work exactly the way that we intend it because that code is going to fire over and over and over again. And here we go. And you'll see it happen. Notice how our speed is just dropping all the time. Okay, that's because as long as our score is 10, this is going to fire. And I also want to make sure that we have bad speed here. So now we need to introduce a variable for, is this the first time that the score is changing? So let's name it something descriptive. I'm going to say speed changed. And we're going to check to see if speed changed equals 1. So if this is the first time that the speed is changing, or at least in this round, then we want this to happen. And actually, we'll probably need to do an if-then block. So let's change that. Because we definitely want this to happen when the speed changes. And then we want to set speed change to 0. Let's see if that works. And then we need to make sure that once we hit that score, we set speed changed to 1. Okay. And again, there's multiple ways to do this. We may actually discover that there's a better way to do this. As we're going through this, we may, we may want to use one of these other controls like repeat until. Let's just make sure that this works. Again, it's not going to be perfect, so we'll have to make some modifications. So that didn't exactly work. So let's take a look. Let's step through our code and debug this and see what's going on. So as we hit the green flag, all of our stuff is set. Our current score and high score stuff is set. But here's where we have our mistake. If the current score mod 10 is 0, which is correct, and the current score isn't 0, then if speed changed equals 1. So when we start our game, we need to make sure that we set speed changed to 0. So let's make sure we do that. And then if the speed is 1, then we change the speed. The problem is the very next time that this loop happens, our speed change isn't 1, so that triggers our else condition, which then sets it to 1. So we actually need to do that setting in a different spot. We can't have it within this loop, because if we do, then this gets triggered every single time that that happens. So let's pull this out and jump back to our original. And as long as our speed change happens after this block, we know for sure that this is going to trigger. So in this case, if the current score is 0, then we want speed change to equal 1, set speed change to 0. And then this fires and says, if speed change equals 1, or sorry, 0, then set it to 1. Okay, and actually I did those backwards. So let's fix that. Okay, so the order that this is happening in now is we're first checking to see if our score is a multiple of 10 and it's not 0. If it is, then we change speed change to 1. And that's it. That's the end of this block. Immediately after that, we're checking to see if the speed did change. Then we change our actual speeds and then set it back to 0. Okay, so let's test that. You may need to add a second condition to make sure that in this case, our current score is not a multiple of 10, because we only want that to change once and then set back when it's not a multiple of 10. Okay, so that's in fact the case. So then let's check here. We're going to duplicate this condition here. Actually, we probably only need this one. And we're going to use that not block. Oops. Oh, I needed an and. Again, this still may not work, so we're just going to iterate through this one step at a time. So far, it looks like it's working. I'm going to jump to the next value, to our 20 value, just to make sure that this still works the way that we're expecting it to. Okay, so you'll notice one issue, and that issue is that it's waiting until we hit the next amount. So it's waiting until we hit the 21 value. So let's make sure we're hitting that at the right spot. Again, as long as this one comes after the first one, we know that they're going to fire in the right order. So that block is going to fire first, then that block is going to fire, and then our whole loop is going to repeat. So that didn't work. And I think it's because of our not block. So I'm setting this back so technically these both should be true. Again, I might just be undoing exactly what we did. Who knows? We need to walk through each step to double check this. So if the current score is divisible by 10 and is not 0, speed changed is 1. But only if it's currently 0. Ooh, and notice how fast that goes up. Even though we're only moving 0.25 pixels at a time, that still moves up pretty quickly. Okay, so let's see if we can step through this again. So we need our score divisible by 10, not 0. If speed changes 0, then set speed to 1. But then We only want this to happen once. We may need to actually have a third condition. So completely off the first time and then every other time. Okay, so let's try that. And actually, maybe we should make these more descriptive. We'll look into that after we're done checking this. This one and then the last one. See if this works. And hopefully that should jump to 1.5 or negative 1.5. Okay, so that looks like it's working the way that we intended. So let's rename these so that they make a little bit more sense when we're looking at this. So speed changed is normal for the first one. And the second one is, this is the first time. So if this is the first time, and this is divided by 0, set it to other time. So basically what this is going through, if we step through this again, just like I talked about, recipe, it'll only do exactly what you tell it to do in the order that you tell it to do it. If the current score is divisible by 10 and it's not 0, and the speed is currently the normal speed, then we change it to, this is the first time that we're changing the speed in this loop. Okay? Because again, if the current score is 10 or 20, then this loop would fire every single time because both of these conditions are true. Okay, and you can simplify this. you know, as you get more advanced with this, you'll learn how to simplify this stuff. You'll be able to use 3 and 4 conditions to check if this is true. But in this case, once we know this condition isn't true, then we say, if it's the first time that the speed has changed, then go ahead and change the speed and set it to every other time. So as long as we're in that loop before we catch the next fruit, which is here. So the score is now a remainder of 1, and the speed is currently at other time, then we change it back to normal, which would then fire this as long as the score is evenly divisible by 10. Okay. Now we can do this exact same thing for the wait time. We currently have these waiting between a ½ second and 2 seconds. We did that initially just so that it wouldn't take too long for the fruits to actually fall, you know, while we're playing our game or testing it. But for the actual game, we may want to change these to some more reasonable values so that the player isn't waiting forever. And now that we have our good speed and bad speed set, we can hide the speed change variable. The player's never going to need to see that. That's just for our internal programming. Okay, so now let's make a power-up. Our last section in our game design portion is to change our mechanic a little bit so that a power-up will slow down the speed temporarily. Okay, so what we're going to do is we're going to make a power-up, maybe pick something. And maybe we'll even do a heart power-up as well that causes the player to get an extra life or something like that. We'll do a muffin. Cats love muffins. So we're going to set this up pretty much the same way that we've set up almost everything else so far. In fact, we can probably even copy most of our code here. I'm going to make this block fall twice the speed of our good speed, though. Okay, so in this case, our power-up slows down just the good items. Maybe we want it to make the good ones fall faster and slow down the bad ones, or vice versa. Whatever you want to do, you'll want to test out your game mechanic modifications, and then you'll want to see which one feels the most fun. You don't want to put the player at a disadvantage, obviously, when they're catching a power-up. So let's change our speeds. Let's change our bad speed and make it slower. And let's change our good speed. Oh, sorry, and I think I picked the wrong one. We gotta. No, we got the right one. If touching scratch, then change bad speed. Change good speed to 1. Okay, now, this is going to have an issue right off the bat because we want this power-up to be temporary. We don't want it to last forever. But we're going to run this just to check to make sure that the power-up actually works the way that it's supposed to. Oh, and we need to delete that. Sorry. Let's try that again. Okay, and then we need to make sure we put in our clone blocks. When I start as clone, we can move all this stuff over. I just want it to match what we have on the other one. So now when we click the green flag, we hide our muffin. We wait a random amount of time. And again, we probably want to raise this for testing purposes. We're not going to change that now because as we're testing, we don't want to have to sit there and wait for the muffin to fall. And we'll have it create a clone. When it starts as a clone, it does everything that the other ones do, but it changes the drop speed and then changes the bad speed too. Okay, so you'll probably have seen a couple issues. One, we have way too many of these popping up. Two, eventually the speed, if you catch enough of these power-ups, causes the bad fruits to actually start going up. So we need to first off fix that issue and make sure that this only happens if bad speed is greater than 0. And actually, we might even want to keep it at a minimum. We don't want to necessarily freeze the bad ones, but you could. It's completely up to you, up to your discretion. But if bad speed is greater than negative 0.25, then we don't want it to do anything. Oh, actually, wrong one. We want the less than operator because we're talking about negative numbers. So if bad speed is less than 0.25, go ahead and do that. Otherwise, if it equals negative 0.25 or anything above, we don't do that. Okay, good. And that's good. So it doesn't matter how many we catch after that. The bad speed doesn't change. Okay, then we need to add our last delete this clone block. Once it hits the ground, again, just so it matches these. And if we step through this, when they click the green flag, we hide that muffin. We wait a random amount of time, make a clone. When each of those clones starts, we set their size to 50%. We pick a random position from left to right. We then show it. We start it dropping at twice the speed of whatever the regular good objects are. And if Scratch the Cat catches it, we change the bad speed and then change speed changed by 1, but only, actually, we don't even need to change speed by 1. We change the bad speed, but only if the bad speed is at least negative 0.25. If it's negative 0.25 or 0, that means that changing this speed would actually increase it to a positive value, which would cause that stuff to start floating upwards, which we don't want. And let's just double check. Bad apples are definitely slowing down. And we can't go past 0.75. Okay, so that's good. So that's our first problem fixed. Our second problem is the time frame. So we can make this something like between 5 and 10 seconds so that these drop a lot less frequently. They'll drop faster, but again, we want them to be rare. We may even want them to go longer than that, because even 5 to 10 seconds seems... Okay. But then the next piece is, as we mentioned, we want this to be temporary. So we need to set some kind of a timer. We need to decide how long we want this to go for. And then, you know, depending on how long that lasts, we can wait to delete the clone or reset the speed back, you know, whatever we want to do. And in this case, we have a couple different ways that we can do that. We can cause the wait or use the wait parameter, which just says if it's touching Scratch the Cat. Sorry, accidentally dragged it into the wrong spot. If it's touching Scratch the Cat, then do this. The problem with the wait parameter, though, is that the wait parameter will pause everything in the program. So let's say we wanted the power up to last for 10 seconds. You'll see an issue here. It should cause everything to freeze on the screen because wait literally means wait. Let's see if that's the case. Yeah, see, so it stopped up here. It's waiting on that first loop. So the wait loop isn't technically going to work. So we need to set up a timer for ourselves. Kind of the same way that we set up the timer for our game just a few days ago, where we wanted the little character to randomly say, or the X to say a random message. We're going to set that up the same way. So let's create a variable and call it power up timer. And again, you might have to play around with the length of time that you want this to go through. But if Scratch the Cat catches this, and bad speed is greater than that, we want the power up timer to go to 300. And actually, it may even be best if we separate this out into a message. So let's do that. Let's create one for power up. Now I'm going to do a little trick here because our power up timer is going to be a certain amount, but we need to make sure that we set the speed back to whatever it was before. We can't just set it to -1 because we may have another power up that changes that speed to something else. So if you did this with a full game, you would want to actually save whatever the current value is. Since we don't have any power-ups that change the speed of the bad apple to go faster, we don't need to worry about that. It's always going to reset back to -1. So we can set power-up timer to 100. And then repeat this until power-up timer is less than 1. So again, as if you've joined us for our previous sessions, this will check for a value of 0 and anything below 0 in the event that we somehow manage to skip past the 0 point. Just for the sake of testing, I'm going to change this back to a 1 to 2 second value so that we're not waiting around too long. Catch that. Timer goes down. Okay, great. And it stops at 0. So once our power-up timer equals 0, then we can set our bad speed back to -1. Okay. Again, I'm going to pick some larger values. Maybe too long. That's exactly 10 seconds. Okay, here's our muffin. The bad apples have slowed down. Timer should run out. And then it resets back to -1. Now, again, you want to play with your values here because in this case, 10 seconds may not be long enough. And we don't, at least at this point, want the player to be able to catch multiple muffins within the same timer period. It's not going to break anything. It just, if they catch another muffin, it resets that timer. And that may be something that you want, and maybe something that you don't want. But now we have a game mechanic where we have a good item, a bad item, and then a power-up that changes the behavior of those items. Okay, so my suggestion to you for the homework for next week would be to try and figure out how to make some additional power-ups that make different changes to the game. It's up to you what you want that power-up to do. Maybe you want it to speed up the apples. I've had students in the past make it so that they have a power-up that makes them magnetic. So the apples, instead of just falling straight down, actually move towards the player one bit at a time. So you can try that as well. Just play around with it. See if you can add some game mechanics and make it fun. One of our awards at the competition is best game design. And a lot of people assume that that means, you know, the general programming or general design. But really what we're looking for is unique coding that offers a unique game mechanic, something that the other games don't have. So give that a try. Again, we'll be around for the next half hour live on here and on YouTube answering questions for people if anybody has any questions. But we also are taking comments on our YouTube page after the fact, and you can always contact us via our Slack channel or our contact form on our website, email, whatever you want. We're here to help you. So if you're trying to get ready before the event and trying to get your students ready, we're here to support you. So please don't hesitate to contact us if you have any questions on the design aspects, the game aspects, the programming aspects, any of that stuff. So next week, we're going to continue on each session for next week because it's our last week of teacher training. We're going to go over some specific use cases that might be helpful for you to know and for your students to know for this year's competition. And then we'll also have office hours. So if you are planning on working on your projects, we'll be answering questions live all throughout next week while you're actually working on them. So feel free to come in with a project, screen share with us if you want us to take a look at what you're currently working on or what you're trying out, and then we'll see you from there. So I will sign off for our live broadcast for now. But again, as I mentioned, the Hangout will still be open, so you can still join to ask questions if you want. And we'll be answering questions on the YouTube channel as well. So we'll see you guys next week. Thanks for joining us. Thanks for watching our videos, and good luck.